All right, good afternoon, good morning, whatever time it is for you. This is the run-through percent yield practice. This will be the final kind of practice assignment for Unit 6. And in this case, we're just kind of tacking on this little idea of percent yield to our stoichiometry calculations that we've been doing. Right? Really, it's the easiest step. It's just kind of needs to be done at the end. All right, so let's jump in. Question number 1 says a reaction produced 374.54 grams of gold. The expected amount was 404.50 grams, right? So one thing that might help you guys out is identifying a couple of terms in here. Expected amount, right, is what we get through stoichiometry, so that's what we call the theoretical amount. All right. It says a reaction produced, right? That's indicating that the reaction was done and it actually produced this much. All right, so in this case, this is our actual yield. All right, so for percent yield, it's always going to be our actual divided by our theoretical, and then times 100. That gives you your percent. All right, so in this case, we will just rewrite this to be 374.54 grams over 404.54 grams, and these are both gold, and then times 100, and I should get 92.584%, and I do have 5 sig figs, so I'm going to take it all the way out to the 5.584%. All right, moving on. So with number 2, right, what we have is a full stoichiometry problem that we need to complete before we can identify the percent yield, right? So in this reaction, we have copper metal, right, and excess silver nitrate produces silver and copper nitrate, okay? Now, in this case, right, we said 12.7 grams of copper produced 38.1 grams of silver. So this is our actual yield. All right? So this means that we ran the reaction and it actually produced 38.1 grams. What we need to figure out is the theoretical. That's our question mark, right? So that's where stoichiometry comes in place. So step 1 has already been done for us. We already have that balanced reaction, so we will just jump right into step 2. We're going to take our given quantity, 12.7 grams of copper. All right. Now, we need to get this into moles. So to get into moles, we divide, and we're going to divide by the molar mass. So in this case, the molar mass of copper is 63.55 grams Cu per 1 mole Cu. Now, cross off our grams, and that'll get us to 0.200 moles of copper. When we round that to 3 sig figs, right? Moving to number 3. We're going to multiply by our mole ratio, so we got 0.200 moles of copper times, let's set up our ratio, going mole Cu on the bottom. We're trying to find moles of silver. We're going to go to our reaction. For every 1 copper, there are 2 silvers, making this 0.400 moles of silver. All right, this number right here is in grams, so we need to do one more step to convert our 0.400 moles of silver into grams of silver, and we do that by multiplying by the molar mass, and we should get 43.1 grams. All right, so we did stoichiometry to calculate our theoretical yield. We already know our actual yield is 38.1, so our percent yield is going to be 38.1 grams of silver over 43.1 grams of silver, and then times 100 to get it to a percent, and we get 88.4%. Oh, number 3. We have 12.7 grams of lithium react with excess copper 2 phosphate. 21.4 grams of copper are produced. So again, we are given our actual amount. All right, we have to figure out our theoretical yield, which means we do need to start all the way up here at step 1. I have lithium is reacting with copper 2 phosphate, so that's Cu3PO4 2. It's going to yield lithium phosphate, Li3PO4, and copper metal. So let's see, I got 3 coppers, I'm going to need 3 there, got 2 phosphates, I'm going to need 2 there, and a 6 there. Moving on. Now I'm going to convert my known quantity into moles. So I've got 12.7 grams of lithium divided by 6.94 grams per 1 mole. That's going to give me 1.83 moles of lithium. Step 3. We're going to take our 1.83 moles of lithium and multiply that by our mole ratio. So we're going moles of lithium on the bottom, moles of copper on the top. We have a 6:3 ratio there. That is going to give me 0.915 moles of copper. And one more step here to get our grams of copper, so 0.915 moles of copper times 63.55 grams copper per mole. And we're going to get 58.1 grams of copper as our theoretical yield. Alright, so to go percent yield and go to actual, 21.4 grams Cu over 58.1. Fix that, over 58.1 grams of copper times 100. And that should give us 36.8% yield when we round to 3 sig figs. Not very good, by the way. All right, number 5. Now, this is a tricky one. Probably won't throw questions like this at you on a test equipment. Maybe we will. We'll see. But in this sense, we are going to work backwards, right? We know the percent yield is 85%, and we know the actual. So the actual yield was 112 liters of hydrogen gas at STP. Okay, so basically we kind of know that end point. We're still trying to figure out what the theoretical yield was, but we're going to do it by using the percent yield rather than stoichiometry, right? And then we kind of essentially work stoichiometry backwards to figure out how much do we need to start with to produce 112 liters, assuming 112 liters was 85%. You guys have all the knowledge to do this, by the way. It's just different. So we do, of course, still need to start with a balanced chemical reaction. So in this case, we have zinc plus hydrochloric acid. It's going to yield zinc chloride and hydrogen gas. And we need 2 there to balance that out. All right. So what we're going to do next is we know we have an actual yield of 112 liters. 112 liters, so let's just write this out. 112 liters of H2 is 85% of a value. All right, so 85% is 0.85 x. So x would be our theoretical yield. All right. Or we could kind of think of it as this is a percent yield question. It could be actual over theoretical equals, and then times 100 equals 85%. All right. So, however you guys want to do this and set it up to kind of make it make sense to you. So, we're trying to solve for that theoretical value right here, just using percent. Right. So probably the easiest thing to do is just to take this equation right here. I'm going to go 112 liters over 0.85 equals X. And then we're going to get 132 liters equals X, right? So this is our theoretical yield. Okay, 112 liters is 85% of 132. All right? So with stoichiometry, it works either direction, right? If I know how much reactants I have, I can calculate how much products I ought to get, right? If I know how much product I have, I can just do stoichiometry the other direction. It's the same process, all right? So I'm going to clean up my screen a little bit up here because I kind of showed you two different ways to set that up. All right. So now I'm just going to follow the steps of stoichiometry at this point, right? But my starting quantity is going to be 132 liters rather than 112. Okay, because with stoichiometry, we have to work with theoretical amounts, right, for products, not the actual amount. Okay, so we were aiming for 132 liters. We got 112. 112 is 85% of 132. So we're going to begin with this number. So step 2, I'm going to convert this quantity, 132 liters of hydrogen gas. Right? Now, this is not a mass, so I'm not going to use the molar mass of hydrogen gas. I'm going to use 22.4 liters per mole. All right, and when I divide that, I get 5.89 moles of hydrogen gas. All right, step 3, I'm going to multiply by my mole ratio. Times moles of hydrogen, moles of zinc, right? And it is a 1-to-1 ratio, so I'm just going to get the same answer, 5.89 moles of zinc. And step 4, I'm going to convert to my desired units. So I'm going to go 5.89 moles of zinc times 65.39 grams zinc per 1 mole zinc. And I should get 385 grams of zinc. Skadoosh.